All right. So on number 5 here, ask you what's the end behavior, right? It gives you this function. Doesn't even make you do it. It tells you it can be written in this form. Now the end behavior, what you're going to see is as x goes to infinity and negative infinity, the y's are going to go to 5. All right. And we can see that on the calculator. I'm going to show you how to get a graphing calculator at home. So while y'all studying so diligently, you can type in Park, spelled P-A-R-C-C, practice test in your Google. And you hit enter. And the first search result there, practice test DC assessments. We're using the District of Columbia practice test that they designed and put up there for the public to use. Algebra 2, computer-based unit 2, click that. Then click start as a guest, click start again. And then up here at the top, there's a little calculator icon, give you a full-fledged TI-84 calculator on your computer. So we're going to plug this function into the calculator. 5 plus 17 over x minus 3. I'm going to go to y equals. I'm going to type in 5 plus, it says 17 divided by, I'm going to put the denominator in parentheses because it won't read it right if I don't. X minus 3. When I hit graph, there it is. Now watch this. I want to know what the end behavior is. I want to know what the x values are when they get really, really large. That's what the end behavior is. So here we on this side, I'm going to go ahead and scroll to the left. Hold it down. Hold the button down. And look at the y values. What are the y values going to get closer to? Look at them go. Look at them go. What do you think they're getting closer to? I'm at 4.7 now. It's getting closer to 5. That's what's happening.
Just go to the graph.
Do what?
Would it be easier to go to the graph?
I am on the graph.
I mean,
The table, you can do it that way too. I just want you to see that what the y values really and really truly do get closer and closer to 5 as x gets larger and larger and larger. That's all I wanted you to see. Listen, this goes to 5. That's what it goes to. So you can say as x gets large, and this goes the same way in the positive and the negative direction. Y gets closer and closer to 5. That's all you got to say for the end behavior. You said number 6 y'all want to see? Oh, now we get to rewrite it in that form. Look, this function is rewritten in this form. We're going to rewrite this function in that form also. This is fun because you get to do your division. Everybody loves division, right? You were taught how to do this using synthetic division. That means you took the coefficients of the numerator, 1, 7, and negative 12, and you put in a little box the opposite of that number right there. That was a positive 2 you saw, you put a negative 2 there. You remember this? Y'all did synthetic division?
no, I wasn't here that day.
We've done it several days.
No, I don't remember how to do it.
We did it.
No, I don't remember how to do it.
Well, you learned it now. These numbers up top came from the coefficients on the top. If you're missing one, like an x or something, you got to put a 0 in there for that, all right? This one's got x plus 2 in the denominator. We're dividing x squared plus 7x minus 12 by x plus 2. That's what we're doing. We're dividing, all right? We're going to bring down the first term. Put a 1 there. We're going to take that 1 and we're going to multiply by what's in that box, and we're going to put the answer there. This is why you got video, so you can go back and learn this. You're good. Then you're going to add that column. 7 plus negative 2 makes 5. And then 5 times negative 2 makes negative 10. And you're going to add that column and get negative 22. And that last number, when you do a synthetic division, is going to be your remainder. Now, I need you to understand something. Now, we're not done. I need you to understand what we just did. We divided 1x squared plus 7x minus 12 by x plus 2. And we get the answer 1x plus 5. This x is 1 degree lower than this x squared. That means this is my p of x. So when I write this, I write g of x equals x plus 5. And this is my r, plus negative 22 over what I divided by. That's all we had to do there. That's what we do. That's the same thing as this. These two are equivalent. This one and this one.
So you're just trying to write the first one the same form as the second one?
Yes, that's what it's saying. It says write this rational function in this form. That's what you're asked to do. Algebra is all about taking something and writing it in a different form. It makes it easier to use or understand. That's what this is about.